What's up guys? In this video, you're going to find out about Svante Arrhenius' acid-base theory. Let's get going. Okay, now we're gonna look at what Svante, the old acid-base guy, came up with. According to Arrhenius, an acid is a substance which increases the concentration of H+ ions when it's plunked into water. So an Arrhenius acid is a substance which increases the concentration of hydrogen ions when it is in an aqueous solution, okay? We're gonna take hydrochloric acid or HCl as our example and pour it into water. When something is dissolved in water, we should write AQ in brackets next to it. That's short for the word aqueous. All that means is it's dissolved in water. When hydrochloric acid is added to water, it dissolves into H+ and Cl-. So there are now more H+ ions in the water than before. By the way, Cl- is called the acid residue. The concentration of hydrogen ions has increased. Therefore, according to Arrhenius, hydrochloric acid is an acid. So far, so good. But you should also remember one more thing. When we have hydrogen ions in water, they react straight away with water molecules. This makes an oxonium ion H3O+. You can also call that a hydroxonium ion or a hydronium ion. Why use just one name when you can have three? Okay, just remember that H+ ions react straight away in water to make H3O+ and don't exist as individual H+. That's fine so far, but Arrhenius hasn't given us a definition for bases yet. According to Arrhenius, if you add a base into solution with water drop by drop, OH- particles will form in the water, the so-called hydroxide ions. If you want to memorize another sentence, try this one. A substance is an Arrhenius base if it increases the concentration of hydroxide ions when dissolved in water. For this, we're gonna take the example of potassium hydroxide or KOH and dissolve it in water again. KOH reacts in water dissolving into potassium ions. That's your positive base residue and hydroxide ions. The concentration of hydroxide ions in the water will also be increased by adding the potassium hydroxide. Okay, so Arrhenius bases form additional hydroxide ions and positively charged base residues. Okay, so far so good. Now another thing. You can also join Arrhenius acids and bases together. They'll form water and a salt. So an acid plus a base reacts to make water plus a salt. Nice! Let's put hydrochloric acid and potassium hydroxide together. In our mixture, we will form H2O and the salt potassium chloride or KCl. Let's unzip everything into partial reactions. First of all, HCl in water goes to H3O+ and Cl-. KOH dissolves in water to K+ and OH-. Then the oxonium ions react with the hydroxide ions to make two molecules of water. Otherwise, K+ reacts with Cl- to make KCl or potassium chloride. If we mix together exactly the same amount of hydrochloric acid as potassium hydroxide, then our solution is neither acidic nor basic. The base and the acid neutralize each other, they virtually dissolve each other. That is why the whole process is also called neutralization. Okay, remember three things for Arrhenius. According to Arrhenius, an acid is a substance which increases the concentration of oxonium ions in an aqueous solution. On the other hand, bases increase the concentration of hydroxide ions. The acid and the base together neutralize each other to produce water and a salt. Well, that's it. See you later.